Bismillahirrahmanirrahim. In this video, we're looking at the vulnerable time for pure Aloha protocol. Okay, what is the meaning of vulnerable time? Okay, what is the meaning of vulnerable time? It is the time in which there is a higher probability of a collision to take place. Okay, a time when there is a chance of a collision to take place. Okay, when there is chance of collision to happen. Okay, a collision could happen in this time, and that is called the vulnerable time. If we know what this time is, and if we stop other devices from sending in this time, when one device is already sending, we can avoid a collision. Okay, we can avoid a collision. We have this scenario here where B is transmitting. Okay, B is transmitting, but before B finishes, C starts sending. Okay, so the end of B's frame collides with the beginning of C's frame. Okay, the end of B's frame collides with the beginning of C's frame, and both packets get lost. In another case, we have the scenario where B is transmitting. Okay, this is the second case. B is now transmitting, and before it finishes, you have A coming in. Okay, so you have cases. Basically, what you need to know in here is that a collision happens when one frame is transmitting and another frame comes in. Okay, interrupts it. So both packets will get lost. Now look at this time in here. Okay, so we are saying that this time here is one frame transmission time. Okay, this is the time it will take to transmit one frame. This also is TFR. Okay, this is also the time when it will take to transmit one frame. So we have in here, let's look at the scenario again. If we have in here B, okay, B is transmitting. Okay, this is frame B, and this is TFR, we said. So we are saying that when is the chance that a collision will happen? If anyone transmits anywhere in this time. Anywhere in this time, if another device comes in within this time, if the frame comes in within this time, there will be a collision with B. Okay? And how can we avoid this? How can we avoid one frame from coming in from behind? Okay? Look at this scenario here. Okay? Now this is another time which is also TFR. Okay? This is also TFR. Now, if we have a frame starting, okay, somewhere here. If we're having a frame transmitting anywhere here, okay, when will this frame go? It will go in here. It will interrupt in it, and it will cause a collision, right? At this place, it will cause a collision. If we have another frame, okay, transmitting somewhere like this, it will still go a little bit. Okay, and again this part will cause a collision. Okay, so what we are trying to say in here is that for a vulnerable time, what we are trying to say in here is that the vulnerable time is this time and this time. So this is the time when there is a chance that another frame will collide with B and cause a collision. So it is only when the frame transmits somewhere here, okay, if it starts, let's say, somewhere here, if it goes, it'll go somewhere like this. It will not interfere with B. Okay, it will not interfere with B. If the frame starts somewhere here also, it will just reach until here and it will not collide with B. Okay, if a frame starts, even if the frame starts somewhere here, okay, before this slot, it will still go before that slot finishes, okay, something like this, and still it will not collide with B. Okay, so to prevent a collision with B, we have to make sure that no one is transmitting. We have to make sure, okay, that no one is transmitting in here, okay, or in here. Okay, no one should transmit in these two frame slots. So this is why for pure Aloha, the vulnerable time is 2 into TFR. Okay, this 2 into TFR. So anywhere within these two times, if B is transmitting and any frame starts transmitting anywhere within this time, okay, it will cause a collision with B. So this is why it is called the vulnerable time. And if a device wants to transmit to avoid a collision, it should be somewhere outside this time, okay? Somewhere here or somewhere here or even somewhere here, it's fine because it will still go like this and there will still be a small time, but it will still stop before B starts, okay? It will still stop before B starts, so there is still a gap, okay? So you have to make sure that any frame, if it transmits, it has to do either before 2 TFR, after 2 TFR in here, or before TFR, 2 TFR, okay? So this is called the vulnerable time for pure Aloha, which is 2 times TFR. What does that mean? It means that in the time that you can send 2 frames. In pure Aloha, you're only sending 1 frame. Okay? So every frame will need 2 frame slots instead of 1 frame slot. So because of that, the throughput for S for pure Aloha is S is equal to G times E to the power minus 2G. Okay? Minus 2G. And the 2 in here we said is because we are having 1 frame taking 2 time slots, 2 frame slots. So the maximum throughput S max is 0.184. Okay? When G is half. What is G? G is the average number of frames generated by the system or all stations during 1 frame transmission time. Okay? So during 1 frame transmission time, the average number of frames that can be generated, that can be made by a system, okay, or all the stations is called the load. But we know that for pure Aloha, the number of frames that can go in 1 slot is half. Why? Because we need 2 slots in pure Aloha. Okay, to send a frame, we are keeping aside 2 slots. So this is why the G is half. because in 1 frame transmission time, you're only sending half. In 2 frames transmission times, you're sending 1 frame. So in 1 frame transmission time, you're sending half. Okay, so this is why G is half. So a pure Aloha network transmits 200 bit frames on a shared channel of 200 kbps. What is the requirement to make this frame collision free? In here, the size of the frame we said is given as 200 bit, okay? And the bandwidth, the channel bandwidth is, data rate is 200 kbps. So the frame transmission time, TFR, is 200 bits upon the speed, which is 200 kbps, okay? And this comes to, so 200 kbps, so that is 200 upon 200 into 10 to the power minus 10 to the power 3, not minus 3, but 3 bits per second, okay? BPS, bits per second, because this is in bits. So bits per second. So these both go, so you have 1 into 10 to the power minus 3 seconds, or 1 millisecond, okay? So you have 1 millisecond is TFR. So the vulnerable time is now 2 times the frame transmission time, as we saw, okay? So it is 2 into 1 milliseconds, which is 2 milliseconds, okay? So this is how it is, okay? 2 milliseconds. A pure Aloha network transmits 200 bit frames on a shared channel of 200 kbps. What is the throughput if the system or all stations produce 1000 frames per second, 500 frames per second, and 250 frames per second? Again, we have 200 bit frames on a shared channel of 200 kbps. So TFR in this case will be, again, 1 millisecond, right? As we saw in the previous example. Okay, so the frame transmission time is 1 millisecond. Now, this says the system creates 1,000 frames in 1 second, okay? So you have 1,000 frames. So you have 1,000 frames in 1,000 milliseconds. 1 second is 1,000 milliseconds, okay? In 1,000 milliseconds. So how many frames in 1 millisecond? When you cross multiply them, you will get the answer 1 frame per millisecond, okay? So in this case, G is 1, okay? And when we put the value in this equation, you will get the value of S to be 0.135, 13.5%, okay? This is the percent value. So when you get this value, when you multiply it to the number of frames being generated in the system, or the number of frames being created in the system by the system, then you will get, when you multiply this with this value, you will get the number of successful frames being transmitted, okay? So in this case, the number of frames we are making, the system is making in 1 second is 1,000. So you have 1,000 into 0.135, which is 135 frames. Okay, so only 135 frames out of 1,000 will be successful. And similarly, you have for 500 frames in 1 second. Okay, so we had 1,000 frames in 1 second, so we had one frame in 1 millisecond. In this case, there is 500 frames per second. Okay, you have 500 frames per second. Okay, frames per second. So it will be half a frame, okay, per millisecond. Half a frame per millisecond. So G here will be half. And in this case, S, the value of S you get is 0.184. When you multiply it with 500, you get 92. So only 92 frames are successful. Example C. In this case, the system creates 250 frames per second. Okay, now this is half the value of 500. So 500 was half the value of 1,000, and this is half the value of 500. So it is 1/4 of a frame per millisecond. So G is 1/4, and S will be 0.152, which means when you multiply this percentage value with the number of frames being generated in total, you will get the number of successful frames, okay, which is only 38. So this was the explanation on the vulnerable time for a pure Aloha network and how this has an effect on the throughput. In the next video, we will look at slotted Aloha.